The microservice latency mystery.
Your microservice latency just spiked from 200 milliseconds to 2.5 seconds. But here is the catch. CPU is low, pods are healthy, and nothing is technically crashing. If your first instinct is to check the database, you are already late to the investigation. Almost every engineer debugs this scenario incorrectly because they look for failures instead of bottlenecks.
What the dashboard shows, trap setup.
The dashboard looks confusingly healthy while the user experience is collapsing. Here is what you see. 1. P95 latency jumps from 200 milliseconds to 2.5 seconds. 2. Error rate stays near 0, so no alerts are firing. 3. CPU and memory usage look perfectly normal. 4. Auto-scaling is already launching new pods automatically.
The first question senior SREs ask.
Senior engineers do not ask which service is slow. Instead, they ask, is this compute latency or waiting latency? Compute latency means the CPU is working hard. Waiting latency means the system is idling while holding onto resources. That single distinction changes the entire investigation path.
The common wrong move. Almost everyone does this.
Most engineers reflexively try to throw more resources at the problem. This usually makes it worse. 1. Scale pods and add more nodes. 2. Increase timeout values to avoid errors. 3. Retry failed or slow requests. 4. Result, latency gets worse and queue depth grows even faster.
The real cause usually missed.
The service is not slow, it is blocked. In modern microservices, this is usually caused by 1. Thread pools waiting for a slow downstream response. 2. Database connection pools becoming exhausted. 3. Downstream rate limits triggering backpressure. 4. Serialized calls added by a recent feature flag.
The one metric that actually matters.
Senior SREs stop looking at CPU and start looking at the internal plumbing of the application. 1. Request queue length at the gateway. 2. Thread pool saturation and worker state. 3. The count of in-flight requests. 4. Downstream dependency response times.
The quick fix that actually works.
You must reduce the pressure on the system immediately before you start deep debugging. 1. Cap concurrency to stop the queue from growing. 2. Apply aggressive rate limiting to incoming traffic. 3. Temporarily disable automatic retries to prevent load amplification. 4. Roll back the most recent feature flag or configuration change. Latency spikes are not fixed by more servers. They are fixed by controlling concurrency. Remember, queues always fail before CPUs do. Subscribe for more SRE and DevOps scenarios like this.